there. So we want to convert this density of 12 grams per cubic centimeter into a different density unit, I guess you could say, of kilograms per cubic meter. You know, a gram is a pretty small unit of mass. It takes 454 of them to make up 1 pound. And a cubic centimeter is a pretty small unit of volume. It's only 1 milliliter. So converting this into kilograms, which is about 2.2 pounds, per cubic meter, which is a much larger volume, the size of a washer or dryer, let's say, we're going to see a pretty significant difference. There's going to be a lot more mass in a volume as big as a washer or a dryer. So I set up the problems here, and I basically did it an expanded way up top and a more condensed way below. You know, our goal is to keep kilograms and to keep cubic meters. So I first started by canceling grams, as you can see here, and converting to kilograms. So that's my first unit. I know I don't want to cancel and I want to keep. Then I started working on the denominator, and I converted cubic centimeters to meters, or meters cubed, by knowing that there's 100 centimeters per meter. Centi means 1/100th, so it takes 100 of them to make 1. I always look at it like, which unit is larger? Put the 1 in front of the larger unit, and then the other number has to be greater than 1. And since centi means 1/100, it takes 100 of them. So notice here we have cubic centimeters, or cc's as it sometimes is called, and we have to cancel essentially 3 of those. So I basically use that conversion 3 times to cancel cubic centimeters. And then when we multiply meters times meters times meters, we get cubic meters. Here it is in a little more condensed way. You can see I have grams still canceling. That's what I did first to keep my kilograms. Then I canceled cubic centimeters with cubic centimeters by essentially just cubing this rather than doing it 3 times. And then you can see here at the end I get that unit of cubic meters that I'm looking for right there. And when I do this, this is going to be 12 times 100 times 100 times 100, or 12 times a million, divided by 1,000. And when we do that, we get 12,000 kilograms per cubic meter, which is a pretty large mass because a cubic meter, again, is a pretty large volume. So working with dimensional analysis is pretty cool. It's a really powerful technique. Just think about this whole diagonal relationship when canceling things, and make sure you are thinking about your unit conversions here, which come from equalities, or conversion factors, which come from these equalities. 1 meter equals 100 centimeters. 1 million cubic centimeters is equal to 1 cubic meter of volume. I hope that helps.